So as you can see in the lathe here, we have a disc. Stick the tool into your thing. Okay, in this instance, this is like a massive disc. This disc is 320 millimeters. The fact here that I can't get behind here and grip it like here on inside here. It's 15 millimeter machined steel. There's a variety of brake discs also laying around here. Hey guys, welcome back to the channel and to another video. Before I go any further, I'd like to thank everybody who subscribed to my channel. I really appreciate your subscription, helping making this channel grow. And I hope, like I said in the past, I hope you find it somewhat informative. In this video now, I'll be making a tool holder for the brake disc skimming tool that I've shown you guys in the previous videos. I'll be putting the brake disc directly into the lathe whilst designing this tool holder, and I'm not using the brake disc holder that I've designed, because for one, it's not totally completed. You'll be seeing that in future videos. And secondly, the brake disc, whether it's in the chuck or in the holder, will be in the same position. So I thought I won't go through all the effort to take the chuck out of the lathe and stick on the holder and stuff, you know. So I thought I'll just stick the disc into the lathe chuck and design the cutting tool holder around that. So I hope you guys enjoyed this video. Hey guys, welcome to my channel again. Welcome to another video. So as you can see in the lathe here, we have a disc of a specific vehicle. So the problem with having a lathe is skimming at the back section of the disc here. The back section. The front section is generally the easiest, because the tool post, you would just bring that up to the disc and then put obviously your tool in here. You can put your tool in here like that. Let me just get a tool quickly. Okay, so like I'm going to use this tool as an example. So you can stick the tool into your thing, and then you generally would be able to skim this side of the disc by like moving it like this, you know, just by normal feed, something like that. Okay, in this instance, this is like a massive disc. This disc is 320 millimeters. This disc 320, that's about the maximum. I could probably take 330 in here still, but I wouldn't really go to that extreme. But probably 330 could fit in here. This one is 320. So there's a few issues that I have, like the smaller disc, and I'll show you after this, and I'll take this one out. The smaller disc isn't really a big problem to machine on here, besides the fact here that I can't get behind here with this standard tool post. Okay, and in this one's case here, if you watch the cross slide, if you watch the bed there, you'll see it is fouling up again. It will foul up against the disc here, because the disc is running quite close to the actual bed there. There's only about a 10 mil gap still there. That's why I say I can probably take a 330 disc still. This is 320. So if I spin this, she spins, and obviously if I feed it more, she touches there, which is no good. So basically this is where I must stop with this feed, you know, with the feed going in like that. That's where I must basically stop. And then as you can see now, the tool post is like this distance, 50 mil or whatever, away from the job. So you can get a long tool in here now, but you generally want to minimize this length here, otherwise you can get all the chatter and the vibrations here. So this is the predicament that I'm finding myself in now, is that I haven't got a tool holder. I haven't got a tool holder to go around here. So I'm going to try to make one up. I'm going to make up a tool holder that will come in here, and I'll go and I got some steel for that, which I will show you in a minute. The variety of brake discs also laying around here. Golf Mark 1 here, Ford Escorts, Cortinas, Capris and stuff like that. VW Polos. The one in the lathe is a Ford Ranger, 320mm. These are obviously smaller. I'll put this in the lathe just to show you the difference that it makes on the tool post. But even with this, the problem is getting behind here, getting to the back end of the disc here. Because ideally when you machine a brake disc, you want to keep everything the same. You want to keep all the axes the same. You don't want to like put the brake disc into the lathe to machine this side and then turn it around, like and grip it like here on the inside here, and then you got to clock it up, all kinds of stuff to get it parallel again. No, that's a bit too much. You want to put it in the lathe and leave it in there and machine both sides without taking it out again. That way you're kind of ensuring that the two sides are parallel. Okay, so I've changed the disc. Now you can see this is now the VW Polo range disc in here. You can see there's plenty of space at the bottom here. So when I move the feed in, it actually clears all that, so the post comes quite close to the drill, to the brake disc. If I move this back, then that's where it ends. This is maximum feed now this way with the Ford Ranger as well. This is maximum feed here, and then the disc is still sitting somewhere out here, much bigger. And I mean, in this case here, if I should put this tool like in here for argument's sake, I could do that, or I could even put a tool in here. But let's say if I put it in like this, and then I could easily machine this face here. Like I would be able to touch it there, and I'll be able to machine that whole face on this side. And there you can see it goes all the way through. So this side isn't a problem really on the smaller disc. On the big disc that I showed you earlier on, this side here is also not really a big issue. It's just that this gap is long, and I won't be able to put it in this post here unless I get obviously a much bigger tool for it. But once again, the problem that we have here is getting behind this thing there. That's, you know, so basically when this thing gets fed in like that, and this thing gets fed in like that, and the tool is in the tool holder, she must be able to, as I feed in, this must be able to cut across at the back here. So that's why I'm going to make this tool holder now to go around, so that I can put this tool in here, and it will be in here, and I'll be able to feed it. Okay, so let's see what the outcome is. So the steel that I've selected for that job is 15mm machined steel. This isn't like flat bar that you generally cold rolled, cold press flat bar or something. This is machined squares of steel. For the tool post, I got this 15mm tool machined steel, and I'm going to work out my design on the whiteboard, and let's see what happens. Okay, so before I start on my favorite board over there, I thought I'll end this video here in order for you guys to prepare yourself for a bit of a lecture in the next one. Because in the next one I'll be drawing out my design on the whiteboard like I normally would, and I try to explain things so that everybody can understand what I'm thinking of, and I try to put it down on the whiteboard in the most simplistic way. There probably could be simpler ways, but yeah, it's what I try to put it down in the most simplistic way so that everybody can understand what my thoughts are and where my plans are going as far as the designs that I have. Whether it works or not is another thing, but yeah, it's all about trying and seeing if it happens. So I hope you guys enjoyed this video. Give it a thumbs up, give it a like if you enjoyed this introduction to the tool holder. Like I said, there will be a few more videos to come. The next one will be on the whiteboard. That will be quite a, you've experienced it in the past, so I'm sure you know what to expect. So yeah, give it a like, give it a thumbs up, hit the notification bell if you want to not to miss out on any of the other videos. Comment, subscribe, tell your friends about it. Until we meet again. Thanks, guys.